Hello my people. So let me show you how you can do the analysis of covariance in R. Remember, the analysis of covariance is just a statistical test that combines features of ANOVA and also the features of linear regression. So mostly it is used when you want to compare the means of two or more groups while controlling for the effect of one or more continuous variables, and the continuous variables are called the covariates. So let me show you how we can do this ANOVA in R using the stroke data. I will illustrate, I will come up with a question and we try to answer the question using the ANOVA test. Now the first thing that you are going to do is to load the packages, that is the tidyverse and also the janitor. The second thing is to load the data. Then the third thing is to inspect the data so that we see the structure of the data. You can see the rows, the columns, and among the columns you have gender, work type, BMI, stroke, smoking status, marital status, and so on. So that is the data. We ensure that all these character variables are converted to factors. That is the data preparation part. Then now the last thing is now to come up with the ANOVA. And remember, we can come up with a question. For example, we can try to see a question like, for example, you can come up with a question like, does BMI differ by smoking status when we are controlling with age? We are trying to see if BMI is differing significantly by smoking status while controlling for age. That is the question. Now let's write the ANOVA model. That is just write model. Model is equals to AOV into brackets. That is BMI. Then you tilde with the smoking status, smoking underscore status. And remember, we are controlling for age, so plus age, then comma, we mention the name of the data. The name of the data is equals to data, like that. Then we run. After running it, we do the summary of the model, so that we can interpret the results. Now these are the results. Now we start with the effect of smoking status. The main key thing that you look at is the significant value or the p-value. So from this p-value, you can notice that it is less than 0.05. So meaning that it's highly significant, meaning BMI significantly varies across different smoking status. That is the interpretation. When you also look at the age effect, look at this, you look at the p-value, it is less than 0.05, meaning it's also highly significant, meaning age has a strong effect on BMI. So generally you can say that both smoking status and age significantly influences BMI, and also different smoking categories are associated with different average BMI values. Also you can say that age is also contributing significantly to differences in BMI. So generally we can say that the model is statistically significant, indicating that these two predictors together help explain variability in BMI. So that is how we can answer that question using the ANOVA test. In case you want to learn more about ANOVA and all the statistical tests, you just reach out to me. I'll be able to guide you clearly so that you understand it very well.